Hello and welcome to this short tutorial video. At the end of this video, we are expected to know the difference between mass and weight. So this is what we are going to discuss today. We're going to discuss what mass is in detail, and we are going to also discuss what weight is in detail, and afterwards differentiate the two according to what we are going to discuss. So now we go straight into defining what mass is, and mass is simply can be defined as the amount of matter in a substance. So there we go. Mass is simply defined as the amount of matter in a substance. So one important fact that we should remember about mass is that taking an object or a substance from one place to another does not change the amount of matter inside it. So we can simply say that mass of a substance remains constant. Okay, so there we go. The mass of a substance remains constant. Taking an object from the earth to the moon, its mass remains the same because the amount of matter inside the substance is the same. So now we can measure this physical quantity mass using an instrument known as an electronic balance or simply a beam balance. So we use a beam balance to measure the amount of matter in a substance. As you can see in our notes below, you are actually given what beam balance looks like. Actually is an instrument that consists of two pans, and in the first pan we place a known mass, and in another pan we place an unknown mass, until when we have an equilibrium of those pans balancing. That's when we can tell that the unknown mass is actually the same amount of matter with the other known mass. So the notes are just given below the video itself. So after looking at the three important points about mass, we can go on to look at the units in which you can measure this physical quantity mass. We can actually measure the physical quantity mass in different units. So the important ones according to the exam are as follows, and how they relate to one another. Okay, so the first one, can measure mass in grams. We can measure mass in kilogram, kg, and finally in tons. So these are the three important units according to the exam which we can measure mass in, and we should state how they are related here. So we have the first one, the relationship between grams and kilograms. We have 1000 grams that will equal to a kilogram, and then we have 1000 kilograms that will equal to a ton. So it's very important that you know how these are related to one another. So from here we are going to mention another important fact about mass. Since we do calculations in physics, you need to make sure that all calculations involving mass, you have to state the unit in the SI unit, which is the standard unit for this physical quantity. So the SI unit of mass is actually kilogram. Okay, so there we go. The SI unit of mass is kilogram. So these are the four main important points that we have discussed about mass, and now we are going to go a step further to determine, or rather calculate, mass using different methods, either calculating the mass of a liquid or simply just the mass of a solid. So this is what we are going to do next. Alright, so we want to determine mass of a solid and mass of a liquid. So it's actually very rather simple to determine the mass of a solid, because you simply use a beam balance by placing that solid on a beam balance or an electronic balance. But for a liquid, it's actually very difficult to determine the liquid mass, since a liquid flows, so you can't put it on an electronic balance. Therefore, you need to use the following simple method. Well, the first thing that you need to do in order to determine the mass of a liquid is simply to measure the mass of an empty, dry container. Container can be a beaker, it can be a measuring cylinder, so on and so forth. So first thing you do is you measure the mass of an empty, dry container, and you record the mass of that empty, dry container as M1. So M1 is actually the mass of dry, empty container. So that's the first step. Now the second step is you simply get the liquid that you want to determine the mass for, and then pour it into this dry, empty container and place it on a beam balance, like in the first step. You pour the liquid into this dry, empty container, place it on an electronic balance, and record the mass as M2. So M2 is simply mass of dry, empty container plus liquid in question. So an emphasis: once we put our dry, empty container on a beam balance, we are recording the mass of the empty container alone. And once we record M2, which is after pouring the liquid into that measuring container and place it on a beam balance, we are actually recording the mass of the empty container and the liquid itself. So in order to determine the mass of the liquid, simply use the formula: mass of the liquid will equal to M2 minus M1. And this is the formula in order to record the mass of a liquid, simply M2 minus M1. And there is how you record the mass of a liquid. So for the sake of the exam, you need to explain in detail and include all these values. If you are asked to determine the mass of a liquid, include the M1 and the M2 and the formula in order to show how you came up with your answer. So this is about mass. Now we want to look at what weight is, and we're going to go straight into defining what weight is. Weight is simply the amount of gravity that is exerted on an object. Alright, so weight is simply the amount of gravity exerted on an object, and since it depends on the amount of gravity exerted on an object, then weight is going to change from place to place. The weight of an object on the moon is different from the weights of the same object on Earth. And then the third point is we measure the weight of an object in SI units known as newtons. So we can measure the weight of an object in newtons. Now we have an instrument that is called a spring balance. Spring balance is simply used to measure weight. Alright, so there we go. Now there are times that you're asked to calculate for weight of an object. In this case, we simply employ formula. So in order to determine the weight of an object, you need the mass and then multiply it with the gravity acting on that object. So this is our formula, where we say the G is the acceleration due to gravity acting on the mass. So it's going to be measured in Newton per kg. or meters per second squared. So that's the G in the formula, and then the M is the mass of the object in kgs. Weight can be calculated using the formula capital W equal to mg, where the G in the formula is the gravity acting on the object, and the M in the formula is the mass of the object in question, but its unit must be in kgs. So this one has to be in kgs, and the gravity is in Newton per kg. So in order to determine the weight of an object, this is the formula that you use. Capital W is equals to M times G. So that's how you determine weight, and that's how we can talk about in terms of weight. Okay, so we have an example on how we can calculate the weight of an object. In the first example, we are told that memory has a mass of 80 kg. Calculate the weight of memory when she is standing on the Earth's surface, where the gravity acting on memory is 10 Newton per kg. And in B of the same question, we are calculating the weight of memory when she is standing on the moon, where the gravity is 1.6. So, in order to answer question, write our solutions and say question 1a, we need to get the variables that we are given in the question, and we need to find out where memory is. So we are told that memory has a mass of 80 kg, meaning that the mass of memory is 80 kg, and this memory, she's standing on Earth. So we are told where memory is. She's standing on Earth, and the amount of gravity acting on this memory is 10 Newton per kg. So we are going to say gravity acting on memory is 10 Newton per kg. Now we want to find the weight of memory. So, like we discussed previously, that in order for you to calculate the weight of an object, you apply a formula. So this formula is as follows: weight is equals to mass times gravity. So before you do your calculations, you need to check that the mass of an object we want to calculate the weight for is in kilograms. And the gravity acting on this memory, we need to know the object, in this case, which is memory, is in Newton per kg. So if we are to check, the mass of memory is 80 kg, so we are okay. We don't need to change anything. And the gravity acting on memory also know and where she is. So we can simply just substitute in the formula. Say the mass of memory is 80 kg, which is 80 like that. And the gravity acting on memory is 10. Then we have 800 newtons. So 800 newtons is the weight of memory when she is standing on the Earth's surface. Now we are given another question of the same, which says what would be the weight of memory when she's standing on the moon this time. So here we have a difference. When she's on Earth, that would be her weight, and when she's on the moon, we still calculate and say our weight will equal to mass times gravity. We ask our question, when memory is on the moon, what is the mass? Well, because mass is the same, doesn't change, that's what we discussed, therefore even the mass of memory will still be 80 kg. So 80 kg, the mass of memory, will not change because mass is the amount of matter inside. So even if we take memory to the moon, our weight would still, our mass will still be the same. The gravity acting on memory will be different though, because we're taught that the gravity acting on memory is 1.6, like that. So multiply it with 1.6, and when you multiply 80 times 1.6, you get 128 newtons. So we can do a comparison here now. When memory was on Earth, her weight was 800 newtons. And when memory goes to the moon, her weight reduces to 128 newtons. So when an object is moved from the earth to the moon, its weight reduces, but when an object is moved from the moon to the earth, its weight increases. So that is very important to note. So we can now go on to question number 2 and see how we can calculate. Here we are given a question to say calculate the weight of A girl which has 40 kg, and B, a pen of mass 30 grams. So here we'll go straight up and go into answering question number A. We want to calculate the weight, therefore we employ our formula to say weight is equals to m times gravity. And what is the mass of what we are talking about? We're talking about a girl, so the mass of a girl is 40 kg, therefore that will be 40 kg multiplied with the gravity acting on this girl. Now in this question we are not given the gravities acting on the girl. So in the event where you are not given the gravity acting on an object, you assume that you are on Earth. So we are going to say, since we know the amount of gravity acting on Earth, on objects, we are going to state that as our gravity acting on this scale. So for the sake of calculations, we are going to say we use gravity acting on Earth as 10 Newton per kg. So gravity acting on this scale is on Earth, it's going to be 10. And this will give us 400 newtons. So that's how we'll calculate the weight of that girl. And we go on to calculate a pen of mass 30 grams. Well, in this case, we can see one important fact. It says we are given a pen, and the pen has a mass of 30 grams. We have a problem. So the mass is 30 grams. And we want to find the weight. So we don't know the weight. And what else should we know? We are also not given the gravity acting on this pen, like we said. Like if you don't have gravity in the question, you assume that you're on Earth where gravity is 10. So therefore gravity will be 10 Newton per kg. So in the event where you have your mass in grams, you have to convert it to kilograms, because during calculations every physical quantity must be stated in the SI unit. So how do we change then grams into kilograms? You need to know the relationship. So the relationship between the two units is that 1000 grams is the same as saying 1 kg. So if you want to find how many grams equal to 30 grams, then we'll say x and make x the subject of formula, and we'll have 1000x will equal to 30. Divide both sides by 1000 by 1000. Therefore our x is the same as saying 0.03 kg. So that's how you calculate your mass there, and it will equal to 0.03 kg. Therefore we can now calculate the weight of this pen which has mass 0.03 kg. And how do we do that? We just say weight is equals to mass times gravity, and we'll say our mass is 0.03 and our gravity acting on the pen is 10 Newton per kg. So when we have a situation like that, you simply say 0.03 times 10, and our answer will equal to 0.3 newtons. That's how you calculate your weight. So we have shown how to calculate weight given the mass and given gravity, and where we are not given the gravity. So we've come to the end of how we can calculate weight of an object. Okay, now having looked at what mass is in details and having looked at what weight is in details, we're now going to summarize by differentiating the two. Okay, so the first one we're going to discuss is the definitions. You can differentiate these two using definitions. So here we are interested in the amount of matter in an object. So here we're interested in the amount of matter in the object. But for weight, we're interested on the amount of gravity exerted on the object. So here it's okay, so there we go. Mass is the amount of matter in an object, weight is the amount of gravity acting on the object. The second point is that for mass is constant, it does not change from place to place. So here the mass remains the same from place to place, it does not change. But for weight, it changes, it varies from place to place because different places have different amount of gravity acting on them. And the other difference we can see is that since mass is just the amount of matter inside an object, we can say that mass is a scalar quantity. This one is a scalar quantity. It only talks about the size of the physical quantity. There's no direction in which this quantity is acting on. But for weight, it's the size of the amount of gravity acting on an object, and it acts downwards. Therefore, there is size and there's direction. Therefore, weight is a vector quantity. Okay, so that's our third difference, and the fourth difference we can talk about is in terms of the SI unit, standard units that measure these physical quantities. For mass, the standard SI unit is kilograms, which is kgs. So for weight, the SI unit is newtons. Okay, so you can also use that as a difference between the two. And the last one, which we can talk about, is the instruments that measure these two physical quantities. For mass, we use beam balance. Beam balance measures the mass of an object, though currently, because of technology, we have it in form of an electronic balance. And then for weight, we use instrument that is known as spring balance. So having looked at these four main differences between the two physical quantities, hopefully you are able to differentiate the two different physical quantities, mass and weight, in detail. See you in another video.